Hi, Courage.
Hi, Tarek.
How are you?
I'm good.
Okay.
You?
I'm fine. I'm great. I'm great. No.
Okay, good.
Hey everyone, did Sarah send the document in the group? If so, can someone please share it with me? I'm not in the group as a WhatsApp group. All right, thank you, Taji. Did sir make an apology or something for class? Not in the WhatsApp group as yet, so I'm just asking.
Yes, he did. You can check the WhatsApp group. He sent a message. Say we'll be here shortly.
Oh, I'm
But
not
he's
in the
not in the
WhatsApp.
group.
All right, thank you, Crosby. I'm not in the group though. Can you tell the admin to add me, please?
Okay.
That's my number in the group chat. In the chat.
You sending up? Oh, sending on my chat. Let me see who admin.
Okay.
Terry?
Yeah.
Yeah, sir, gonna have to add it. Sir is the admin and another number. I don't know who is that.
Oh, okay. All right. No problem.
So when sir come here, ask him to add him.
All right.
Good evening, students.
So you're echoing when I talk. I think you have to mute on the audio.
Not anymore.
Oh, you could. Oh.
No man, thanks.
Sir, could you please add me to the WhatsApp group again? Um,
Okay, all right. Just send me a message so that I can do it. I don't want to stop to do it now. Right. So I right. So apologies for just coming in. And I want to give you a little grace period for the Bijan who doesn't know. And I want to give you a little grace period to get between classes, or on a Tuesday when I have you at 5 to get to a safe place to have class. But tonight I had one of my 94-year-old mothers celebrated her birthday, and every time I say I have to go because I have a class, she says no, just 5 more minutes. And those 5 minutes wouldn't go, and I said no, I must go now. But we don't have cake yet. I was like, oh God. But anyhow, thanks for understanding. Um, when I saw the time coming, I was like, oh goodness, what do I do? But I need to cherish these moments because I don't know how much longer she's going to be here. So I'm hopeful that she'll be here for quite a while because she's in good health. So yeah, so all right. So oh Lord, okay, I have it here and I'm looking for it. So I sent you something early this morning. I was a little tired last night, so I really never sent it off. And then I got up early o'clock to do some prerequisite overrides for students, and I I'm not seeing, sorry. And then I went to bed. So I sent it off early this morning. So it still would have given enough time to get going. Mhm. Okay. What am I looking for, Lord? Oh, all right. Um, Tariff. Let me see if I can put it in the. Um, the math channel. All right, there you go. Papa, Curry, just check the message, please. All right, is everybody here connected to the WhatsApp? Bijan, you got connected to the WhatsApp? Tony's here, Tiana.
No, sir. No, sir. I sent you a message.
All right, let me just put this into the. All right, please join the WhatsApp from that link. It's now in the chat. Let's check to see. Tiana, can you send Tiana, Joanna, and Kianda message, please, to them to come and join the class? Can you send them a link to the class, please, Tiana? Thanks.
Okay, sir.
Mhm. All right, so I'm just going through the list just to ensure that those of you here should be here, and all right, good, that looks good. All right. Okay, so how many of you? No, that's Lobitos. I don't want Lobitos rule. How many of you were able to look through the handout that I sent you this morning? Everybody got a chance to look at it?
Yes, sir.
All right,
Yes.
good. Good. Any questions? You understand what is happening there?
Yes, sir. Just when I differentiated something, I got something different.
You got something different. All right. So maybe I made a mistake with something. All right. So we'll soon look at that. All right. Thank you, Courage. Lotto, I hear you said yes. Were you able to? You followed everything?
Not really, sir.
Not really. Fair enough. I like your honesty.
I see.
No, I like your honesty. What about the rest of you though?
Yes, sir. I followed up to some part of it. So
Mhm.
yeah.
All right. I like your honesty.
Can someone resend the PowerPoint, please?
Can somebody resend the WhatsApp link, please? Thank you. So if you're talking, we're not hearing you. Remember when you share your mute.
Thanks, Terry. I don't know why that happens though. I need to go to my settings and see if I can undo that. Thanks, Papa. Let me see if I can do it from here. Yes. So what I was asking is if you can see my screen.
Yes, sir.
All right, good, thanks.
Yes, sir.
Nice. All right, so let me see. All right, looks good. So I'm going back to my shared screen. All right, so some people are saying that they have, oh, now I get what Courage is saying in terms of differentiating, because in order to do the critical points, she would have had to differentiate f of x. So you're saying when you differentiated f of x for f dash of x, Courage, you're getting something different from what I got? That's what you're saying, right?
Yes, sir. Just a
Okay.
little, this sign.
That's the sign. All right. Got you. Got you. At first, when you said that with the differentiation, I was like, differentiation. But I remember that I gave you, I'm looking at the question now when I scroll up. And I remember I gave you something that says find the critical points. Now, remember, we would have done critical points up to the latter part of Calculus 1. Critical points again appear on the Calculus 2 syllabus. What it comes as mainly though would be multivariable functions. What we did last semester was single variable function. So single variable, y was equal to something in x. Multivariable function, you're going to have f of xy is going to be equal to something in x and y. And we need to know how to deal with those. And even before I reach, I'm not going to reach here for now. I'm not going to reach here for now. But even before I reach there is a full question on the exam paper on multivariable function for 20 marks. I'm just saying. There is always a full question on multivariable function for 20 marks. Some of the past papers that you look at would be 25 marks because of the structure of the exam. I can't tell you what the structure of the exam will be for now, but there is a full question on the exam paper, normally on multivariable functions. I'm just putting that out there from now. I'm going to say to you, do not allow Calculus 2 to run away and leave you, because Calculus 2 will come with the premise that you understand something. I will not be able to go back in all cases to refresh your memories. So you have to be on top of things. You have to be on top of things. You must be on top of things in order for you to survive. All right, so with that said, let us go. So it says given f of x is equals to x.
Sorry, quick question before you start. When will Educatsoft be open?
No, I did I send it though? Yeah, man, I sent a request to Educo International for them to assign courses for me. And I have not checked back. The truth of the matter is I did ask. I asked when was class yesterday. I asked on today's what, Wednesday? I asked on Monday. Yes, right, I asked on Monday for those assignments to be done. But the truth is I have not checked. Let me just log on to Educo. I did not check. So chances are it is assigned and I have not checked. EUCOSOF. Thanks for the reminder though.
No problem, sir.
So I would just also say, hey, when I'm supposed to bless me know Jesus, you know. That me I tell you no. I'm supposed to glad say that I know Jesus, because had it not been for him, some of you wouldn't be here. 2022, 2023. Is this term 1? No, it's not data signed. It's not data signed. Oh Lord, I need to talk to them. All right, let me go back to this. All right, so Find the horizontal and the vertical asymptotes. Now remember to find the vertical asymptote first. To find the vertical asymptote, the denominator is going to be equal to 0. The vertical asymptote, the denominator is going to be equal to 0. So whenever you get, and remember now, when we're talking about asymptotes, we're talking about rational functions. What are rational functions? These are functions that contain a numerator and a denominator. There's a function containing a numerator and a denominator. That's what a rational function is. We speak about asymptotes when we are speaking about rational functions. All right? Only rational functions will have asymptotes. And I will show you in essence what it looks like. If there's anyone here that did foundation concept 3 with me, would have and should have a better grasp of what these asymptotes are. Because when I did graphs with you then, I would have gone through the whole gamut with you on what these graphs look like. I'm not sure if I can get into a foundation concept 3 and project it instead of drawing it, so it is that you can see what it looks like. Now, to find a vertical asymptote, you're going to set the denominator equals to 0. So you're given a function, and I'm just going to mark upon this thing about that I have here. You're given a function. Let me see now, what should I use? Let me use, right. So you're given a function. We're going to set the denominator. We're going to let this denominator be equal to 0. We're letting the denominator be equal to 0. All right. Now, when we set that denominator equals to 0, see it right here, so this is it. We're going to be solving. So we're undoing the process. Now, to undo the square, we have to find the square root. We're undoing. All right, undoing the process. So we're going to find the square root. No, we have to do the square root of both sides. So can't just do the square root of one side. It has to be for both sides. All right. Now, when we find the square root of both sides, we're going to be left with x minus 1 is equal to 0. Why, sir? Because, of course, when you find the square root of 0 is equal to 0. Know that you have a simple equation. Simple equation. What we're going to be doing right there is to add 1 to both sides. To add 1 to both sides. And in adding 1 to both sides, what we're doing there is we're adding 1 to both sides. And no, that's not what I want. I want you. The additive inverse, and then we're going to end up with x equals 1. So we know what value the vertical asymptote is going to be for x equals 1. All right. And then for the horizontal asymptote, the numerator is going to be equal to 0. The numerator. So the horizontal is the numerator, the vertical is the denominator. Can you remember that?
Yes, sir.
Yes, sir. Write it down and practice it.
Yes, man. Every time.
Again for me, please, sir.
Say it again, Lotto.
Can you just repeat, please?
Now I'm just saying that the horizontal is going to be with the numerator and the vertical is going to be with the denominator.
Okay, okay.
Yeah, man.
So, sorry, one question. When you're dealing with asymptote, you always get a fraction. So you always get a numerator and a denominator.
A numerator and a denominator, yes. And I'm going to show you why shortly. Yes.
So you're saying that horizontal, you use the numerator, and vertical, you use the denominator.
There you go. There you go. Okay. So what I want you to recognize with this one here in particular, that the numerator originally is x, only x. So you're setting the whole numerator to be equal to 0. So x is equal to 0, right? You don't have to solve anything because already they tell you that x is equal to 0, don't it?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Mhm.
All right, good. So we know what the numerator, we know what the where the vertical
Horizontal.
the vertical and the horizontal asymptotes are. Yeah.
Mhm.
All right, good. So we've evaluated that. Now the other part of the question now says to find the critical point or points, the relative minimum, the maximum, and points of inflection where they exist. So you notice I put the S for points in red.
Really? Mhm.
Yeah, because sometimes they don't tell you that it has 1 point or 2 points. They may say to you where they exist. So you may end up saying, oh, it has only one critical point, but in truth, in fact, it has more than one. So, when we're doing calculus 1, once it says critical points, it has more than one, right? And I showed you how it is that you can find out how many critical points you'll have, right? I don't know if you remember, but I did show you. But anyhow, let's go. Let's go. So for critical points, dy by dx is going to be equal to 0. So this is where Courage says, sir, I disagree with you. And that's fine. She's allowed to disagree with me. So let's go. So f of x is equals to x over x minus 1 all squared. Now, for those of you who would have wondered why, even before I said good afternoon yesterday, I gave you 3 questions to start getting your practice. And those 3 questions were placed within the grace period that I normally give to the class, a 15 minutes grace period, because I didn't want you guys just to sit and wait on me. Or the other way around, for me to sit and wait on the rest of you, but to give you an opportunity to start practicing, because not because you're now in calculus 2 means that you don't need to differentiate or integrate. Yes, you do. So you must remember the integration process. You must remember the differentiation process. So now it is that this question asks us to do critical point. And in order for us to get critical point, we have to find dy by dx to find the critical values and then substitute to find the critical points. And if we're classifying, we have to find the second derivative, right? So we have to go up to at least the second derivative in this question. So let's go. Let's go. It's a fraction. So I'm going to go the denominator. F dash of x, the denominator, times the differentiation of the numerator, minus the numerator, times the differentiation of the denominator, all over the denominator squared. Let me know if, ouch, let me know if one of the questions that I gave you yesterday was similar to this one here that I'm now doing on the board.
Yes, sir. It's similar.
All right. Can you see why I know I had to give you that question? Yes, no, maybe so.
Yes, sir.
Mm-hmm. No, man. But don't worry too greatly about it. You will be fine. I just want you to be a little bit diligent, and you should be able to get through with it. Are you okay with that line so far? Is there any?
Yes, sir.
All right, good. All right, so now f dash of x is going to be equal to, when I multiply that, I'm going to get x minus 1 all squared minus 2 times x is 2x times 1 is still 2x, 2x times x minus 1. And Bijan says, sorry, you have to put the 1? I'm going to say to him, no, So I'm now going to put the 1 there. So now I'm going to say this is now x minus 1 to the 4th power. And then now I'm going to say f dash of x is going to be, oh, blow. So I'm going to say, I can take out x minus 1, take out the lower of the 2. Boom. I'm going to have a x minus 1 left minus 2x all over x minus 1 to the 4th power. Now, what is important is all of this will cancel that and leave out with a remainder 3. That's what it says. So now, f dash of x is going to be x. Let me rewrite it out. X minus 1 minus 2x all over x minus 1 to the 3rd power. F dash of x is going to be equal to minus 1 minus x over x minus 1 to the 3rd power. Courage, are you still there, hon?
Yes, sir. That's what I got.
That's what you got?
Yeah.
So it could be written either or. Could be written either or. Either here or there for your answer. So you're okay with what it is that I have? Okay, so what do I have there?
No, it's not, sir, hold on a second. The R answered it.
Aha, because you see the R answer come
Mhm.
right back to my R answer here. So that's why Courage had a problem with it. Because I'm just looking at it now because I was, oh, ouch.
So the R answer there, two minutes actually.
All I did was just factor out the negative sign.
Mm.
That's all I did was also factor out the negative sign.
Oh, hold on, let me process it. So we use minus 1.
Mm-hmm. See the negative sign, see the negative sign right there, sir?
Yeah. We'll look it up out there.
Hey, can you just scroll up a bit? Let me see something. Oh, okay, sir. Okay.
So whichever one you use, you should end up with the same answer. Are you okay? Vision, what you say?
Yeah, follow it, sir. The R1 kind of stress me out.
All right, do me a favor. Let us use the, all right, what I'm going to ask you to do for me, I'm going to ask you to let f dash of x be equal to 0. I'm not going to use the R1. We're going to use minus 1 minus x over x minus 1 to the 3rd power is equal to 0. Now remember, when you have 0, it's going to be 0 over 1.
Mm-hmm.
All right? Solve that for me, please. I give you 2 minutes. I'm going to step away for 2 seconds. Just going to get a water break. 2 seconds. I'm going to ask you to finish this question. Set f dash of x to be equal to 0. This is f dash of x. And solve for x. Let me know what f dash of x works out to be. Give me half a second, please. Water break. All right. All right. Are you hearing me? Let me just check. Okay, you're supposed to be hearing me.
Yes, sir.
All right. So you notice what I did before I left was to put 0 over 1, because 0 over 1 is equal to 0. 0 over 1 is equal to 0. So this is me saying, what this is saying to me is f dash of x is equal to 0, which is what it is that I was asked to do. To find critical point, f dash of x must be equal to 0. But 0 over 1 is 0. Then so when I put 1 over 0, that is undefined.
So I thought we were using the answers from the horizontal asymptote.
Asymptote?
Yeah, and
I'm going to show you now. I'm going to show you now, Courage, how all of this ties in beautifully. So remember when we're doing stationary points, we found the critical points, the turning points or stationary points. We found the point of inflection. We classified those and then put on a graph. This one here now includes a fractional version where it is that you're going to also include the asymptotes there. So what I'm going to do, I'm going to actually show you how all of this ties in and show you how the asymptote comes into effect. All right.
okay.
But yes, we're going to be using the asymptote, but I'm not going to be using the asymptote just yet. It's me working everything first and then tying everything together. All right, so I'm putting that to equals to 0. So when I have two fractions separated by an equal sign, I always cross multiply. So look at what is happening here now. That cross multiply. So when we cross multiply, I'm going to have -1 minus x times 1 is equals to 0 times x minus 1 to the third power. We know all of that is equals to 0. And we know that it's just going to be -1 minus x. And what is going to happen is going to be -1 is going to be equals to x. So that's my critical point. X is equals to -1. See my critical value? Come down here. X equals -1. Follow me so far?
Hold on. In an exam, sir, what if you know?
Oh, can you just go back? I want to see the negative. If it, oh, you were okay. Okay.
Let's be John. When I go into exam mode.
We have to remember the exact point. Them like I said, this is the horizontal asymptote, vertical asymptote. You have to write them out. Oh boy.
Yes, I have to be.
Yes.
Don't worry about it. Today's just the second class. You have many more classes to get it perfect, man. It's good, man. Others have done it, and I'm sure you can do it.
No, but I say no.
Tell me about it. Remember, you have only 2 courses left here.
Miss, sorry, but they remind me.
All right.
Pressure.
I had last summer. I did calculus 2 last summer, and I had about most of the students in the class. Had just a calculus 2 out, and I tell them, and I fought with them. we had class on a Saturday evening, and when them now learn, sometimes at 8 o'clock, now I say, 8 o'clock, I'm going to drink my soup, you know. At 8
So, you know,
o'clock, we'll
one
come
thing
back
for me
and
like last time, so I did the whole edicus of sitting just online sitting, man.
you know, but guess what? It's what we have now, you know, Bijan.
Yeah, I realize I have to go push my brain.
Yeah. So we can't fight what we have. So if you have a flash out, you can't complain, say you're hungry. You have to go eat the flash out. Yeah, man, that's it stay. But the point I'm making though is I had a group of maybe about 11 or 12 students who needed to finish. You know what was a proud moment for me when I went to graduation, and it wasn't last summer, it was the summer before, I believe, because they graduated last year this time. And when I saw those students on the graduation, well, graduating, was a good feeling. So every time you feel like this is it, remind yourself, two more,
I know you
two
get
more.
to me. You get to me done
All
it.
right, all right. Now let's go. No, you can't call me now. I'm in a class. You can't call me now. I'm in a class. Oh, sorry. Sorry. So 1 minute, please, guys. Okay. So when your person call you, you know you have to answer him, right? So forgive me. So where was I? All right, Lotto, you asked me to go back up. You wanted to see something. Do you see what it is that you're looking for?
Yes, sir. Yes, sir. I was looking on where you have the equal to 0. I was wondering the 0 with the bracket x minus 1 cube. I was wondering, but I realized that is you're just working with the negative 1 minus x equal to 0, and then you subs and get the 0 and get negative 1 equal. I was wondering if we're doing anything with this side with x minus 1.
To the third.
Yes, I was one.
Yeah.
But
Just remember the x minus 1 to the third is being multiplied by 0.
So it's equal to 0.
Right. All right, got you. All right. So now, you recognize that it's only one critical point we get?
Yes,
critical value, sorry, critical value. Right. What is wrong with listen to me, just behave yourself here. All right, so it's just one critical value we have. Now remember, to find the critical point, we have to substitute the critical value into the function, remember?
Yes, sir.
All right, good. So what I'm going to do now, I'm going to put x equals negative 1 into f of x. But remember, recall, I think that was f of x, don't it?
Yes, sir.
No, it's x minus 1 to the second power. Oh, come on. So therefore, f of negative 1 is going to be equal to negative 1 over negative 1 minus 2 to the second power. It is very important for us to have a square and not the cube, because when you raise a negative number, to an even power, the answer is going to be positive. But when you raise a negative number to an odd power, the answer is going to be negative. So it's very important that you see what it is that you're doing. So this is going to be, what is this now? This is going to be negative 1.
Hold up, sorry, 1 second.
Mm-hmm.
Go again, how you get the minus 2?
No, it's not supposed to be minus 2. It's a foolishness me right on something.
Okay. Sure.
1.
It's supposed to be 1.
Okay.
I just put it here to see if you're paying attention, and is you alone paying attention? Right, so let me tell you how your teacher head work now. So I am working ahead. My mind is processing the question a step before you, because what it is that my mind just did a while ago was to add negative 1 to negative 1 to get negative 2. So that's why I put the negative 2 there. So forgive me.
No, sir. I try to follow. So long as we pick it up, I mean,
yeah, man. So I'm going to have negative 2 squares, because minus 1 is minus 2. So it's going to be minus 2 squared. And minus 2 squared is going to be equal to positive 4. So it's going to be 1/4.
Mm-hmm.
All right. And and this is a negative 1 that we have up here now. So it's going to be negative 1/4. It's a negative 1 we have, so it's going to be negative 1/4. And there you'll see a negative 1/4. So compare. So compare my answer there to there, and therefore my critical point is going to be -1, comma, -1/4. Really not difficult, but it takes a little time for it to process.
Okay.
So you're gonna finish it at f -1, f of -1. You have to do f of -2.
F of -2. Remind me now where you get -2 from, Nato, please.
Right, you have f of -1, and then you have -1 over bracket -1 minus 1 squared, and then you have f of, so I'm asking if you're gonna do the sum, finish the sum right there, or you have to have f of -2 equal -1/4.
All right, no.
I'm gonna put equal beside that and finish.
Oh yeah.
Oh.
But guess what now? Guess what now? May I try figure out when me get -2 here, so?
Sir, I thought me just
I wonder too, sir.
What I did is
Yes, you do it late last night, sir. Yes, because I feel with the
And that's
-2
why
now, I think it is something else. You just put the answer that you have right there. And then.
my eyes them they get dark.
Okay, sir. That's what I'm.
Hold on, then let me see something. What this question was asking, because I got only.
Ask for critical points, and it asks for.
Yeah, but remember, critical point is when
Well,
is when it's equals to 0. Why is this thing doing this to me? All right, so yeah, it is. Yeah, it is. It is just one. It's just one critical point I'm seeing. Yeah, that's one critical. See, one critical value. Whenever I get two critical values. Okay. Right. Okay. Got you. All right. So I want to take note of this here now. So the question, note the question asks for critical points. Remember I told you that there was an S right there. Now the denominator is a perfect square. So when you look at the function, the original question is f of x is equal to x over x minus 1 all square. And this suggests that there are two values of x, but it so happens that the values are the same. So this value up here that I have right here is actually supposed to be -1, not supposed to be -2. So that's an error. Oh, I know I'm the one that is pressing on the stuff. That's why it keeps shifting. Okay. All right. I hope I don't do it again. All right. So just bear that in mind. Now we need to determine the nature of the critical point. So remember, critical point is when dy by dx is equals to 0. Critical point occurs when dy by dx equals 0. Critical point occurs when dy by dx is equals to 0. To find the nature of the critical point, I am going to find the second derivative. To find the nature of the critical point, I'm going to find the second derivative. I must find the second derivative. All right? So let me see if I can find some space here now. What was the first derivative again? Which one we use? -1 minus x over x minus 1 cube. So recall f of x is equals to -1 minus x over, is it x minus 1 or 1 minus x? X minus 1? X minus 1.
X minus 1, yeah.
X minus 1 cube. So now, f double dash of, matter of fact, the rest of the day is only lot of courage and vision that I'm hearing, you know. Want to the rest of on the day?
Yes, sir.
Yes, sir. I'm here.
sir.
Yes, sir.
Okay.
We're here.
So there, son.
No, man, the silence kind of deafening, you know. As 4 voices in my ear, man. No man, why you don't on, man. So if we get too silent, we just unmute and and clear the throat here, please. One knows on the day.
Okay, sir.
All right, cool. So we need to find f double dash of x. Now the function looks ugly, but we still need to find the second derivative. It's a You see, because I'm using a function like this, let me show you what is going to happen. And every time I do this, I remember when I came to the face-to-face class and I had an interaction with Miss Courage. And I don't want me not to follow it, you know. So I can put that in parentheses here. Because you see, we're not using the second notation. Remember what I did for the first notation, for the second notation was to say negative and then open my parentheses and say x plus 1 or 1 plus x, whichever one, however I did it. But this time, no. Right, but most of you, if not all, prefer this notation -1 minus x because they never saw how it is that I was able to factor it out. No, you have to be very careful. You have to be very careful that you're using -1 minus x. You see, whenever you work with negative signs, you have to be respectful. You have to be respectful. You have to call it Mr. Negative or Mrs. Negative. Can't write and say negative. All right, let's go. It is always the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. So let's go. The denominator times the differentiation of the numerator. Whoa! When I differentiate the numerator, what do I get?
-1.
Thank you. -1. So the denominator times the differentiation of the numerator minus the numerator minus times the differentiation of the denominator is going to be 3 times x minus 1 to the second power times the differentiation of the inside, which is 1. All over the denominator square. X minus 1 cube square. You see, you don't have to worry when the function looks ugly, you know. When the function looks ugly, follow the methodology, follow the sequence of what it is that is being done. Just follow the stuff. If you follow the steps, you can't go wrong. Just follow the steps, you can't go wrong. Follow the steps, you cannot. So the most ugly and difficult question you'll find yourself being able to solve. Why? Because you're following the steps. All right, so let's go. 1 times x minus 1 to the third power is x minus 1 to the third power. Wow, that one look real ugly though. Minus. I'm gonna write out this in because I don't want to make no mistake. 3 times another 3, so I'm gonna put, you know, I'm gonna put that 3 up right in here. So
I left out the -1.
no man. Which -1? The x minus 1 all squared? That one?
The one after this cube. Yeah.
Oh, there's a negative sign up in front of it, don't?
Yeah.
She's correct. This is a -1 right here. So that one comes there. She's correct. And then now I'm going to have x minus 1 to the 6th power.
So the yellow then not work.
Yeah, I'm
You know
just,
what?
yeah, it's kind
Oh,
of
no,
hard to
sir,
see.
that yellow then not work. But that not go nowhere tonight, sir.
After me think some yellow sexy. Jeez,
Yes, sir, that not work tonight.
you think me swear some yellow sexy.
Might. By your side, not this side. It not work tonight, that's all.
All right. It not even erase neither.
We can use the next color over it.
Yeah, I'm gonna see if I can.
See, come on now.
So that's negative that, and then let me try the wrong side of North Street. Put this up.
Not gonna work with me neither. I will use it green.
You can't see the purple something there.
Yes,
So
sir.
Yeah,
yeah, you can just show that the negative sign go right there. So all right, there's a minus sign that is missing right here though. The denominator times the fraction minus the numerator, so a minus sign supposed to be right here. Minus the numerator, so that's minus 3 into minus x minus 1. All right, that looks good to me now. So all right, so f double dash of x is going to be equal to x minus 1. What do I factor out?
X minus 1 to
the
second power.
Very good. X minus 1 to the second power. Excellent. And that's the only thing I can factor out. What is going to be left is going to be negative x minus 1 to the first power. 1 is left. Minus 3 times negative 1 minus x all over x minus 1 to the 6th power. And then all of that cancels.
X
And
minus
4 is going to be equals to, let me just write it out first. Negative x minus 1 minus 3 times minus 1 minus x over x minus 1 to the 4th. So f double dash of x is going to be now equal to, this times this is going to be negative x plus 1 plus 3 plus x, and that plus x plus my 3x over x minus 1 to the 4th, which gives me 2x. 2x plus 4 x minus 1 to the 4th power. 2x plus 4. Yeah, man, are we so bright, you know?
Yes, so that's what I got. But you have the negative sign in front.
I have a negative sign in front.
Yeah.
Yeah, I don't know why.
Final answer. I'm seeing a negative sign.
Yeah, man. I'm seeing what you're saying. So my f double dash of x up top has a negative sign in front.
Yeah.
Sir, because I was wondering, when you reach at the second to last line right there, sir.
How this a talk?
After
How this?
Also,
You know,
After sir.
you know, so me send a message. Me not talk to you know. You know, so me
Yes,
send a
sir,
message.
I respond to you, man.
Me no
Respond.
want hear nothing from you. I'm vexed.
Respond to you, sir.
After me send message, I not say nothing to the teacher.
No,
All right,
I
want
did.
to, you respond. All right, if you
Yeah.
respond, I forgive you.
Yes, sir.
Go ahead, honey.
Yeah, I was asking to go back to that. Like the all right. So when you had the negative x, negative bracket, you have the x minus 1 to the third power minus 3x. And you multiply that by -1 minus x. The next line, go up further.
Right here, sir.
No, next one. Yeah, but when you come down here, I kind of lost right down here. So when you have factor this, the next line. So I understand that line. Yeah. So this is where I got lost with the negative sign.
Mm-hmm. Yeah. I hear you, but I don't know why it is that I came up with this negative sign right there.
Okay.
I don't know where my headspace was when I was doing the question.
So I guess utterly want to know where the negative sign right in this line went, because it's not at the next line.
See to yourself. See to
Because
yourself.
you can't. Oh.
So x square.
No,
Okay.
because find the square root of that sign.
Oh, gotcha.
And I get that.
Yes, sir.
Is this negative sign talking about, right, utterly?
Yes.
You see it right, sir?
Because I hit with a leave. One of that would a leave out.
Yeah.
You take out that out of it.
And then that's how I multiply this now and see to yourself again.
Mm-hmm.
Yeah.
Yes.
And I use to multiply that to get this negative x right here, so?
Negative and positive.
Positive.
And then,
yeah, so this negative times this negative one giving me positive 1, and this negative times x is negative x, yeah.
Positive.
Oh, so this answer correct and not the one I have right now.
But I'm going to tell you the honest truth.
Sir, we get it, man. They're asleep.
we don't know why we put negative sign. I'm going to look back on it now because my headspace must have been going somewhere. Because it has it will have an effect on the I can check it. I'm going to leave it as it is. I'm going to check it afterward. I will check it afterwards. When we plot the graph.
Sir, may I beg you appeal, sir?
Mm-hmm.
When I give you exam, I put a negative sign, man.
I know we can't promise you that, right, Papa?
Always
because guess what? The man them know where the students normally make mistakes, and as a result of that, them set the questions with the common errors that students make to see if the students understand what is happening.
So is anyone set me up a field?
No, it's just that they wanted to make sure that they understand what is happening. Put it this way: life is not black or white.
Nor do they want us to pass easily.
You have many areas of gray. You have children and say, yes, they're going to be the best. Bam, them turn out to give headache. You get one nice little work, bam, you have one supervisor who you can take tea to. You buy one car and say, yes, thank you, Jesus, never car. Bam, the car start your problem. So life has a lot of grays. All right. I'm going to leave that as it is because Courage and Lotto say that they're getting this answer here. But
and you get it too?
Yeah, I get it too, you know, but
yeah.
we don't know where. Anyway, all right. So we're still going to question this up here, so though.
Okay, sir.
And I think it's an error. I think it's an error because I mean, see, there was an error right here, so.
Night,
yeah,
sir.
Yeah, a night. Yeah.
Say it again, Bishop.
Sir, I was saying that you probably put the negative one because you were using, yeah. Yeah.
But I don't know what I was doing. But anyhow, that's why it is important for you to check over your work, But we will figure it out when we do the graph, because what I'm going to do, I'm going to actually plot the graph on using Desmos. So Desmos will give us an accurate stuff. And then we can see, God forbid, if when we plot it, we're getting this negative 1.8 as the Y value for the turning point. If it is a positive 1.8, we know it was a clear error. But if we get negative 1.8, so we're just going to end class, and that is going to be your homework for Tuesday, God's willing. All right. All right, so let's go. Point of inflection, second derivative. So let me ask you a question now. So you got this for the second derivative, and you got green. You got this for the second derivative, or it is without the minus sign?
Without a minus sign.
Oh.
So is it all? What is?
All right. I don't know what one. Teacher does not know what one. All right. Part 3 says to something must have been going to part 3 to sketch a graph. Something must have been going through my headspace by.
So I want to know is it?
It's about let me see, a question like this. Hold on there now. Hold on there. Hold on 1 minute, please. Are you back? Hold on. Guys, give me half a second, please. Here. Don't move, don't move, don't move. Go on to the second one for me, please. Please and thanks.
Sir Heidi.
Ouch.
No, 89 still.
Yes, about to Sir Heidi.
Yeah, I wrote it down still. It's 2x plus 4 and x minus 1 to the 4th power. Okay.
All right. So tell me now. Wanna figure it out yet? Or it is that I was sleepy? Wanna go on? We have 10 more minutes.
We're here.
Oh, come on, so I can't leave the teacher alone, All right, let me see now. All right. I don't even know. All right, you know what I'm going to do? I'm going to use the answer that we got, which is a 2x plus 4 over x minus 1. No, but hold on. I've already found the second derivative, right? So all I need to do is just set that equals to 0. Okay. So all we need to do is set that one equals to 0. So we're going to say f double dash of x is going to be equal to 2x plus 4 over x minus 1 to the 4th, which is equals to 0. And of course, 0 is the same thing as 0 or 1. And every time I have something like that, I'm always going to be cross multiplying. And when I do cross multiply, I'm going to end up with x, 2x plus 4 times 1 is equals to 0 times x minus 1 to the 4th. I know that equals to 0. And I have 2x plus 4. So I'm going to have 2x is equals to negative 4. Divide both sides by 2. And then x is going to be equal to negative 2. Let us see if sitting around then. Oh, no, you know, it wouldn't be, because it means that I would have to carry the negative sign to the denominator, because I end up getting the same value for x here. But that is possible because it means that my negative sign, I would have carried my negative sign to the denominator. So it wouldn't make much of a difference. And even if I carried it to the numerator, I'd have had negative 2. You know, so this thing don't keep long battery life. All right, yeah, because it will be negative 2x minus 4. And yeah, if I multiply both sides by negative 1. Okay, yeah, so I still end up with negative 2. All right, so remember now, when you're finding, what are we finding here? And the point of inflection, remember the point of inflection, we have to now go ahead and put in the substitute it into the original function. All right, so remember, let's remember. Remember, original, always the original function. So remember the original function is f of x is equals to x over x minus 1. All right. So now f of negative 2 is going to be equals to negative 2 over negative 2 minus 1 all square. That's negative 2 minus 1 is negative 3 all square. That don't make no sense, you know? Okay, it does. Negative 2 over 9. So the point of inflection is going to be equals to negative 2 comma negative 2 nines. So we are okay with this one then, right?
Yes, so I have a question.
Go right ahead.
The relative maximum. Can you go back to the relative maximum?
Thank you, because you know I didn't even classify it, you know. Go ahead, ask a question.
Yeah, when we did it in the first semester, I think it was just to find out which of the points is maximum or minimum. I was wondering why you put them into brackets and making them a point. And we didn't have the minimum.
Yeah, but remember no. Yeah, it would have been the critical point would have been here and not, so it is -1, -1/4. So you are correct. So the relative, so this here is just telling us that it is going to be a maximum, the y value. So it is going to be -1, -1/8, because that is where the critical point occurs. Remember? So the critical point occurs at -1, -1/4. So it is going to be not the -1/8. The -1/8 is telling us that it is a relative maximum. So she's correct. We're not doing no more network here. Yeah, so that's correct. All right. I have 3 minutes. I want to quickly do something here so I can tie this into what it is that we're doing. Oh, come on, how do I do this now? DESMO. Graph. What's the function again? X. All right, let me just share the screen so you can see what I'm doing here. New share, Microsoft Edge, Desmos Graph.
Sorry, I'm muted.
Thank you. I don't know what is happening every time I share, but thanks on. X into 1 minus X or X minus 1?
X minus 1.
Thank you. And this is to the second power, right?
Yes, sir.
Yes, sir.
All right, let me just bring this down. And let me spend, come on, Sir Shand, what is wrong with you? All right, so let me explain what is happening to you now. And I want you to, okay, good. For one point, I didn't remember how to do this stuff. All right, so let us speak now about the vertical asymptote occurred where again? X equals -1, right?
Yes.
Yes, sir.
All right, good. How do I write on this thing here now? Can I? Oh Lord, Lordy. Am I able to write on this? It is not giving me an option. All right, so let me see if I can show my one. Okay, now I'm showing my one. So this is my X equal. This is here the one is right?
Yes, sir.
All right, good. So watch your graph. You see this line, this piece of the graph right here, so the one to the left, it gets close and close and close and Rockstone. It close and close and close and close and close. It gets very close to X equal 1. The line that is inside here, watch my cursor. the line that is inside here between the two red lines is my x equals 1. And that x equal 1 that x equal 1, it means that the graph will never, ever, ever able to cross that x equal 1. That's the boundary for the vertical asymptote. The boundary for the vertical asymptote is x equal 1. It means that the graph can't cross x equal 1. Can't cross it. That's where it is. So x equals 1 is the boundary for the graph. So this graph will come this way, x equals 1. But guess what? The other piece of the graph too, you recognize that the other side of the graph gets very close to 1, but never ever crosses 1. Irrespective of where it goes, it gets very close to 1. Both lines will get very, 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 very close to 1. See, I reach 53, I reach 56, I reach 58, I reach 60, and I go all the way up to 100 plus. And it will never, all it does, it gets closer to 1, but it never kisses 1. It doesn't matter how far up I go. That x equal 1 is going to be my boundary to the left and the right of it. It's my asymptote. There's no way that the left side of the graph can be crossed over that x equals 1. All right, so that's why I get my vertical asymptote. Now the horizontal asymptote, we got the horizontal asymptote to be x equals 0. Now look at what is happening here. Let me look to the left of it first. So x equals 0. So anywhere along there on my x-axis, if you look at the graph, it gets closer and closer and closer to the x-axis. See, when it reaches negative 35, how close it gets. Negative 42, even closer. Woo, negative 49, close. Blow, you know, so by the time it reaches negative 100, it starts French kiss, right? Because it gets so close that not even the Holy Spirit can get through. Look how close it gets. Can you see that? It looks like it's sitting on the line, don't it? Talk truth.
Yes, sir.
Yeah. But guess what? It is not, because when I expand it, you can see that it's not kissing. Negative 116.4, negative that. So it gets closer and closer and closer to it. But when I expand it, you recognize that it really isn't kissing. And guess what? It happens on the right-hand side also. Blow, it starts kiss even earlier up on the right-hand side. Right? But when I go, you will see that, there's a little space for the Holy Spirit right here. So, yeah, man, enough space right there. So, but when I go further and further, it will get closer and closer to it. So what I'm saying, so that's the horizontal asymptote. So the horizontal, of course, is on the x-axis, and the vertical, it will be on the y-axis. All right. So that explains the x equal 1 and the x equals 0. Courage, you see that? You're asking earlier.
Yes, sir.
All right, good. Now, there was something else. What was the critical point again?
Point.
There was something.
Negative 1 and
and a quarter.
I want to show you the. Sorry. Say it again, Papa.
I got draw a graph and an example, sir.
I'm if I tell you, there's something that I'm looking for, but I'm not seeing what I'm looking for. All right. I was going to show you something. So we got. I can't find what I can't find my slide that I was working on. I think I closed it accidentally. What we got for the turning point again? The critical point. Negative 1 comma.
Negative 1 comma negative a quarter.
Okay. All right, so it is giving us right here. It is giving us here -1 and a -1/4. It is giving us this point here for the critical point. We said -1, -1/4, right? -1/4, -0.25, -0.25, -0.3, 0.35, -2.4, yeah. So this is going to be 0.5, 0.05, 0.1, 0.15, 0.2, 0.25. Okay, so -1/4 is going to be at this point. All right, let me just cut back to see if, okay. So at this point on the graph, it's where the graph starts to turn. This is the point where the graph starts to turn. Where is the point of inflection again? What value we got for the point of inflection again? Please remind me.
2, -2/9.
2, -2/9.
-2.
Oh, -2?
Yes, sir.
What is 2/9?
-2. -2/9.
What is 2/9? 2/9. Oh, come on, Mr. Shand. All right, check to see if -2/9 is the same thing as -0.222.
Yes, sir.
That's it?
Yes, sir.
All right, so the point of inflection is right where my thing is. I'm trying to get it back at 2. Okay, see it right there. So come on. -2, -0.222, which is -2/9. So that is going to be our point of inflection. So that's what that is. So our values, our calculations actually lines up with what it is that we're getting. All right. I think you guys tune me out now. Bijan, you way too silent, you know. It's like you say, you know what, maybe I had enough of this for tonight.
No, sir. Pay attention, man.
Are you following what is happening?
Yes, sir. Yes, sir.
All right. What I'm going to ask you to do for me, I'm going to generate another question. Not tonight. I'm going to sleep it off. I'm going to, be fresh at it. I'm going to generate another question. But what I want you to do, having done the question with you tonight again, I know I sent you the solution early this morning. What I will ask of you to do for me is to at some point in time tomorrow, get some rest tonight. At some point in time tomorrow, you're going to go through the question again. Desmos graph is an open source. You can, if you want, you can save the app to your phone. And if you don't want to do that, you can just go on, use a browser to access it, plug in the function, study what the graph and how the graph looks. Because in the exam, of course, you're not going to have Desmos to show you how to plot the graph. So I'm going to show you how to plot the graph because you will need to know the asymptotes are easy to put in, but you will not need to put in the critical point and the point of inflection on these graphs, right? We never did any of these in calculus 1. So don't be too alarmed if the graph part is not seen just yet. If I were you, I wouldn't be worried. Just make sure that you know how to calculate the vertical asymptote, the horizontal asymptote, and make sure that you know how to do the critical points. We can work on the graph. So that's what I'm going to promise you for tomorrow. Yeah, I'm going to promise you for tomorrow's what? Tomorrow's Thursday? Or tomorrow's Thursday?
Yes, sir.
Right. I have so many deliverables to do. But anyhow, I'm going to see if I can sort that out. All right. So Thanks for coming out. I really hope that you guys learned something tonight. Go ahead. Somebody saying something?
Sir, I was saying that I have a question for you.
Go ahead, hon.
Sir, it's about lending.
All right. Talk to me after that. Talk to me outside of this, please, on it. Any other question? All right. Sleep tight. Before you do that, I'm going to ask you, Calculus 2 students, to start getting into the groove from now. Don't wait until the middle of the semester before you start doing the revisions. Start
So
doing the revisions from now.
mid-semester face-to-face, sir.
Say it again, Papa.
Mid-semester face-to-face.
Yeah. So so
Sadly.
something like this, so something like this I go upon the mid-semester, don't it? Yeah, judge for real. And there are other things that we need to do. So if you know me well, I don't think you do, but I'm not one who rushed. Well, I'm hoping that you will agree with me. I'm not one who rushed through the topics. I try to get you guys to understand what is happening before I move on, much to my peril, because when I recognize that I'm not finishing the syllabus, I get very jittery. But I'm going to ask you to start working, please. I prefer for us to finish the syllabus and then we have time to go back over than for us to be trying to cram everything. Finally, critical points, multivariable function is a staple on the final exam. Sometimes they give the question for 20 marks. Sometimes they give the question for 15 marks or 14 marks, and then find a 7 mark or a 5 mark or whatever the situation is. But nonetheless, you'll again get a question that carry enough mark for the stuff. Sleep tight. Have a good one.
All right, sir. Thanks again.
That's in my brain, you know.
Yes, sir.
Okay, sir.